You look out the window and see white mist streaming from the wingtips. Most people assume it's to prevent a fireball, but that's not the real reason. It's about weight, not fire. Every aircraft has a maximum landing weight, and that's the key.
This is Wings and Wrecks. How machines fail, and what saves the people inside them.
The truth is structural. Every aircraft has a maximum landing weight. For a Boeing 777, that's 554,000 pounds, while it can take off at 725,000. That gap is mostly fuel, and it's the reason fuel gets dumped. So when an emergency forces a return shortly after takeoff, the plane is heavy with fuel. Dumping that fuel brings the weight down to a safe landing limit. It's not about fire, it's about keeping the plane intact. Why such a big gap between takeoff and landing weights? For a Boeing 777-300ER, that difference is over 200,000 pounds, the weight of a fully loaded 737. That's a lot of extra stress on landing. Landing stresses are brutal. If the plane is too heavy, components can fail, collapsing struts, blown tyres. So regulators set a hard limit, the maximum landing weight. That's why pilots need to shed weight before landing. So how does a pilot shed that extra weight? Fuel Jettison, a system that pumps thousands of pounds per minute out of wingtip nozzles. On a 747, each nozzle can dump 3,000 pounds a minute. How do pilots shed that extra weight? Fuel Jettison systems are installed on most large aircraft, from the Boeing 777 to the Airbus A330, allowing them to dump fuel at rates of up to 3,000 pounds per minute through specialised wingtip nozzles. But not every plane has this. Narrow-body jets like the Boeing 737 lack a Jettison system. Their only options: burn off fuel by circling or land overweight. That's a trade-off we'll come back to. A Boeing 747 can dump over 2,000 pounds per minute from each wingtip nozzle. In about 15 minutes, a heavy 747 can shed enough fuel to reach its certified landing limit. But 15 minutes is a long time in an emergency. If dumping fuel is effective, why don't pilots always do it? Time. In a time-critical emergency, every minute spent dumping is a minute the plane stays in the air. Sometimes that's a luxury they don't have, so they may skip it and land overweight instead. When seconds count, crews may land overweight instead. The aircraft is certified to land safely at up to 105% of its maximum landing weight. No mandatory inspection required, but there's a catch. An overweight landing isn't free. The aircraft must undergo a thorough inspection before it can fly again. A trade-off. A few minutes of dumping versus hours of maintenance. What about the environment? Regulations require pilots to dump above 6,000 feet, high enough for the fuel to vaporise into a fine mist before reaching the ground. That's the environmental safeguard. In 2020, a Delta Boeing 777 dumped fuel over Los Angeles. The fuel vaporised at altitude, but some residue drifted down, causing minor skin irritation to a few people on the ground. That incident raised questions. Why over a populated area? The plane had an engine failure shortly after takeoff and needed to return quickly. The crew followed procedure, but wind carried the vapour toward the city. It was a rare case. Most fuel dumps happen over oceans or unpopulated areas like United's 2019 dump over the Pacific. The fuel evaporates high above, leaving no trace, so the LA incident was the exception, not the rule. A common fear is that dumped fuel rains down as a flammable liquid. But what actually happens to that fuel at altitude? The reality is far less dramatic and far more controlled. Regulations require fuel to be dumped above 6,000 feet, ensuring it evaporates into a fine mist. By the time it reaches the ground, it's a harmless vapour. So no, it doesn't rain fuel. The real concern was never fire from fuel on the ground. It was always structural. The risk of a £775,000 plane hitting the runway too heavy, its landing gear collapsing. That's the core reason. Why would pilots skip dumping? Dumping fuel takes time that may not exist. When an engine is on fire or a passenger is in cardiac arrest, pilots sometimes choose to land heavy instead. It's a calculated decision. Aircraft are certified to land at up to 105% of the maximum landing weight without mandatory inspection. An overweight landing is routine, a calculated trade-off between time and maintenance. But where does that landing weight limit come from? It's determined during certification testing, where engineers subject landing gear to extreme loads. The limit ensures the struts, tyres and brakes can absorb the impact without failure. During certification, landing gear is tested to 150% of its rated load. That safety margin means an overweight landing isn't instantly catastrophic, but repeated heavy landings can cause hidden cracks, so inspections are mandatory after each one. So where exactly does the fuel go? Wingtip nozzles are the most common, but some aircraft also have tail-mounted Jettison masts. The goal is to expel fuel far from the fuselage to avoid ignition risks from engine exhaust. When an emergency strikes, the crew runs a quick checklist. They assess time available, fuel weight, and landing distance required. If time allows, they request a fuel dump from air traffic control, who vector them to a designated area. Air traffic control plays a key role. They clear the airspace below and around the dumping aircraft, ensuring no other planes fly through the mist. They also coordinate with approach control for the eventual landing. Most fuel dumps occur over oceans or large lakes. The fuel evaporates quickly, and any residue that reaches the water disperses. Environmental studies show no significant impact from occasional dumps, thanks to rapid evaporation. Remember the 105% rule? That extra margin allows a 717 to land at up to £582,000. Above that, the landing gear might fail, but even at 105%, the aircraft must undergo a thorough inspection before its next flight. The inspection after landing overweight is no quick walk-around. Mechanics check the landing gear, structure, brake wear, tyre condition, and even the airframe for hidden stress. It can take hours, delaying the aircraft's return to service. For narrow-body jets without Jettison systems, the only option is to burn off fuel by circling. A 737 burns about £5,000 per hour, so losing £20,000 takes 4 hours of flight time, too long for most emergencies. Despite the drama, fuel dumping's rare. Most emergencies happen after takeoff, when the plane is still light, or during cruise when fuel is already low. Only a small fraction of emergency landings involve a fuel dump. But what about the fuel that does reach the ground? In rare cases, wind can carry vapour over populated areas, as seen in the 2020 Delta incident. However, the fuel is so finely atomised that it evaporates almost instantly, leaving only a faint smell of kerosene. Regulations require dumping above 6,000 feet to ensure the fuel vaporises before reaching the ground. At that altitude, the air is cold and thin, helping the fuel evaporate into a harmless mist. This is why most dumps happen over oceans or unpopulated areas. Environmental studies show that occasional fuel dumps have negligible impact. The fuel evaporates quickly, and any residue that reaches the ground or water is rapidly broken down by natural processes. So while it may look dramatic, it's actually quite safe. Despite the drama, fuel dumping is rare. Most emergencies happen after takeoff when the plane is still light, or during cruise when fuel is already low. Only a small fraction of emergency landings involve a fuel dump. It's a tool pilots have but rarely need to use. Fuel dumping is about weight, not fire. It's a rare, controlled procedure, a tool pilots use to protect the aircraft's structure. Next time you see vapour from wingtips, you'll know it's engineering in action.
If you want to know why machines break and how crews fight back, subscribe. Next up, our next video.